All right, today we have the tricky lesson of this chapter, and that is the altitude on hypotenuse theorems. So just because it's a theorem, we're not going to necessarily be doing proofs, but we're going to be solving for pieces of triangles. So what we have here is, it says if an altitude is drawn to the hypotenuse of a right triangle, ABC. So notice in the picture here, we have the big triangle, ABC, which is a right triangle. And then we have the altitude drawn in. So I'm going to just highlight that here. So H here is the altitude, okay? Remember, the altitude is like the height of the triangle. It's perpendicular to the base and goes to that vertex perpendicular to the base. So that's the altitude. So it says, if an altitude is drawn to the hypotenuse of a right triangle, then, first of all, the two triangles formed are similar to the given right triangle and to each other. So in other words, we have triangle ABC, the big one, similar to triangle ACD, the left side one, similar to triangle CBD, the right side one that's formed. Okay, so, and the reason it is AA. Because let's say if we look at the left side one, we have the right angle, which we have in the big one, and then we have angle A in common. So AA, similar triangles. And then same thing over here, we have the right angle and angle B in common. So AA, similarity. So all of them are similar. Now, since they're all similar, their sides are in proportion, and we can write proportions for these triangles. So it says, first of all, the first proportion we can write, and we'll give it a different marking here. The altitude to the hypotenuse, okay, so that is H in this case, okay, on our drawing, is the mean proportional, remember that means geometric mean, between the segments of the hypotenuse. And that is the pieces. So we're going to label these, pieces. So we're going to call this the left part of the hypotenuse, and this the right part of the hypotenuse. Let me fix that. Let me just write part. Left part, right part, okay? And where this right here is the whole hypotenuse, okay? And so what that means is, so B means this, that, and I'm going to put it in general terms, not with the X's and the H's and everything that we see here, but that is we'll just say the left part over the altitude is equal to the altitude over the right part. Okay, so that is one that we need to memorize, okay? That altitude splits that hypotenuse into two pieces, and the altitude is the geometric mean between those two parts of the hypotenuse, okay? So that is one important formula. Then we also have C. And C says either leg of the given triangle. So we're going to call this the left leg. Remember the not the hypotenuse, but the other sides of a right triangle we refer to as legs. And this is the right leg. So we got the left leg, left part, right part. And then altitude and whole hypotenuse. Those are all our parts of this triangle. So it says either leg of the given triangle is the mean proportional, or in other words, geometric mean, between the hypotenuse of the given right triangle and the segment of the hypotenuse adjacent to that leg. So let's decipher here. What that means is the whole hypotenuse over the left leg is equal to the left leg over the left part. Okay, so either leg is the geometric mean. So the left leg is the geometric mean between the whole hypotenuse and the segment of the hypotenuse adjacent or next to that leg. In other words, the left part of the hypotenuse. So that's one. We also could write a similar proportion for the right leg, or the right part. Yeah, the right leg, right part. Okay, so we have those two. Now, in general, okay, if you just want to remember one thing, in general, that means whole hypotenuse over leg is equal to leg over leg part. Okay, so I'm going to do it like this. That takes them both into account. So in general, whole hypotenuse, leg, the leg part. So it's either the right leg part or the left leg part. So we have two things to memorize. Two things. And again, the altitude is the geometric mean, or the leg is the geometric mean. Now, as a reminder, since they are right triangles, if you have two sides of a right triangle, you can also use the Pythagorean theorem to find the third side. So that's an option too. Okay, so if you had like the left leg and the whole hypotenuse, you could use the Pythagorean theorem to find the right leg. So we've got Pythagorean theorem, and we have our two proportions here that we can use. So let's see how we're going to do this. What I like to do, first of all, is label my picture. So in other words, left leg, left part, right part, altitude, right leg, whole hypotenuse. Okay, so we've got all the parts here. So what do we have? Well, it looks like we have the altitude, the left part, and the right part. So that was the first proportion that we learned. And that was like, let's just call it left part over altitude equals altitude over right part. So putting in what we know that 3 over x equals x over 9. And we're going to do that. So x squared equals 27, square root. You do end up with 3 root 3. Yes, I know these things. Oh, so that is CD. Okay, so that was one of the things we need to find. So that's CD. Now, AC is the left leg. Okay, that's AC. So for that, remember that is whole hypotenuse over leg equals leg over part, okay, in general. And so here that means whole hypotenuse. So whole hypotenuse in this case is 12. We can see it's 3 plus 9. So this is going to be 12 over AC equals AC over 3. So doing the cross product, AC squared equals 36. AC equals 6. All right, next one. Again, I'm going to label this. So left leg, left part, whole hypotenuse is x plus 21. This is the right part, right leg, altitude. Okay, so we need to find AD. We need to find X, which is the left part. So we're going to use, and we have the left leg. We kind of have the whole hypotenuse. So we're going to do whole hypotenuse, hypotenuse over leg equals leg over part. So here that means X plus 21 over 10 equals 10 over X. Now, when we do the cross product, we're going to get X squared plus 21X, equals 100, or X squared plus 21X minus 100 equals 0. If we factor, that's going to be X plus 25, X minus 4. So X equals negative 25 or 4. Now remember, it can't be negative because how can we have a negative length? So 4. So AD equals 4. Now, this next problem is enrichment only, okay? What you need to know is the stuff we just did, okay? Solving for these missing parts. And we're going to get more practice on that in our next day. I don't want to say Monday because it might not be Friday when somebody else is viewing this in the future. But in our next class, we're going to spend another day on this section to get more practice with doing those proportions. But just for fun, because we can do proofs just for fun, let's take a look at this proof. So we have PK perpendicular to JM, RK perpendicular to JP, KO perpendicular to PM, and this is all our given. So let's see. PK to JM, that's that. We have RK to JP, and we have KO to PM. Okay, so we've got all these similar triangles, right? And altitudes and all that good stuff. So we know that perpendiculars mean right angles. So I'm just going to say, I'll just say them. Angle KRP and angle KOM and angle PKM, right angles. Okay, and so because of that, because they are all right angles, we have our similar triangles. Let's take a look at what we have here. See, PO is this piece, okay? PM is the whole thing. We've got PR is that piece, and PJ is this whole thing. So it looks like we have like part over whole piece, part over whole piece, and legs and so forth. So we are going to be using this here. We're going to be using this proportion that is whole hypotenuse over leg equals leg over part. Okay, so if we look at these two triangles here, let's see. For this first one, we have whole hypotenuse. So for, let's say, let me just say it, let me highlight it. Highlight this triangle right here. Okay, so for that, oops, for that triangle right there, we have, oh, this is still, we'll call it the same thing. We have PJ, whole hypotenuse, over PK is equal to PK over PR. And now in our other triangle, let's make it distinct here in this one. For that one, we have whole thing PM over PK equals PK over PO. And that is, you know what? I'm going to do it like this. I'm going to do it like this. Okay, we're going to do it like that. All right, so number 4, we're going to do means extremes. So that's going to be PJ times PR equals PK squared. And we have PM times PO equals PK squared. And that is means extremes. And then here, let's see, what do we want to prove? PM, PO. Oh, we're just going to set them equal to each other. So PJ times PR is equal to PM times PO. And that could be transitive or substitution. Either way, because they're both equal to PK squared, right? So that means they're equal to each other. And that's it. So like I said, not a lot of emphasis on this proof. What we do need to emphasize are these 2 examples at the top of this page. That is what you need to do. And to do that, you need to know those 2 boxed formulas, those 2 boxed proportions.